Hello, welcome to my channel. Now we move to the curvilinear motion problem number 7. Okay, so in this problem, we look at the robot arm that can extend and rotate the length as the rate is given. Okay, so we can see that the robot arm already has some inclined angle theta that act with x-axis. So this arm, the problem said that this arm is rising and extending at the same time, which means that it was rotated and extend the radius at the same time. The angle theta equal to 45 degrees. The angular velocity is given at 12 degrees per second as a constant rate. The extension L right now is 0.6 meter with intention rate of r dot equal to 0.25 meter per second, and the extension acceleration is L double dot equal to minus 0.2. Now, let's say that the fixed segment of the arm has a length of 0.8. In this case is 0, I believe, 0.8, 0. Okay, so 0.8 to 0.9. Okay, I'll show as we go. We has the length of the certain length as a constant value. Now the question asks to determine the magnitude of the velocity v and the acceleration a of the grip point P. Also express v and a in terms of the unit vector I and j. So given that the r equal to 0.9 as a fixed condition plus 0.6, which is the extension, then the radius rate on how it would expand or enlarge is 0.25 meter per second. Acceleration is minus 0.2. Now, moving on to this part, the information about the data. I say that theta dot is equal to the 12 degree per second, but we always work with radius per second, right? So we have to convert that into a radius per second unit. Firstly, have 12 degree multiplied by pi radius divided by 180 degree. That degree will cancel out, and then we left with radius. And then to determine the velocity vector, we then recall the velocity vector equation shown here. Substitute what we know, which is r dot, r, and theta dot as a radius per second unit. Combine and make a simplified term, we get that velocity vector equal to 0.25 er plus pi over 10 e theta. Okay. Now the magnitude, just power 2 of the component, summation together, it gets 0.4 meter per second as the magnitude of the velocity. Then the acceleration. Then we again recall the acceleration vector, substitute what we know inside each component, and then we get ourselves the simplified version shown here. You may notice that theta double dot here is turned into 0. That is because the theta dot is said to have 12 degree per second as constant rate, meaning that the acceleration of the angular acceleration will be 0. Okay, so the magnitude of the acceleration will be the power 2 of each two component and 0, and finally equal to 0.28 meter per second square. So that's it, the end of this problem. Thank you so much for watching. We'll see you in the next concept or problem that we will study together on. So thank you so much for watching. See you on the next video.